In section 10.5, we learned the rules for dealing with basically polynomials in the variable x. Again, remember our goal here is that if we're given a nice formula for a function f of x that we would use to either model a situation or perhaps generate a graph, then our expectation is that we should be able to find a nice formula for the derivative so that we have a formula that will tell us the slopes of our f of x graph. So on the worksheet that you have attached to this video, you'll see a review of the rules here, and I've just used these little suits to represent anything, any expression at all. But what I really want to go through here are just some examples, and so I'll show you down here how to do these, and I'll try to keep this pretty streamlined so that you can refer back to this if you get lost on any problems, because this really does contain an example of all the different things that you'll see as far as this particular rule goes. So, so this is our favorite kind of expression right here. This guy looks like a number times the power of x, and this looks like a number times the power of x. So anytime we see a number times x to a power, we're in business as far as our rules go. The right way to do this is to ignore the number, and by ignore I don't mean remove it, I mean ignore it. So ignoring it means don't do anything to it. And then we'll apply the derivative rule for x to the 7th. Well, the derivative rule for x to the 7th is that the derivative should be 7x to the 6th. The power rule is that the power of x, that's here, so the 7th power of x comes down front, and then this power gets reduced by 1. So that's it, that's the rule. The rest of the process is to just repeat that same rule on all the pieces and ignore the signs that are connected to them. So if there are plus or minus signs here, we just leave them alone. So by ignoring them, what I'm really saying here is just leave them where they are and don't try to apply any rules. The derivative of 3x squared, again, I ignore the 3 because it's the number multiplied in front, and then my derivative rule says that the derivative of x squared should be 2 times x to the first power. Again, the original power was 2, so that came out front, and then the power of x remaining should be 1 less than the power before. Now, for entering answers into the course compass system, it makes sense to simplify that, at least as far as multiplying the numbers out. And we normally don't write x to the first power, we really normally just write x. So that would be a good way of entering the answer into the course compass system. Okay, so we have to just be persistent about using the rule as it is. The rule works regardless of what the power looks like. So, so for example, even if the power is something that I don't really like negative numbers, I really don't do anything different. I ignore the 2 because that's multiplied in front. The derivative of x to the minus 6, according to the power rule, that power, minus 6, comes out front. And then I have x to the power. Now the power here should be 1 less than negative 6. Well, 1 less than negative 6 is negative 7. Okay, so it's very important when the number up here, the power is either a negative number or a fraction, to really stop and think about what does 1 less than that mean. That's a place where it's easy to make a mistake. Here are a couple of other terms that, that sometimes cause people problems. The derivative of 5x is just 5 because the power of x that was there is 1, and 1 less than 1 is 0. So the 0 power is a constant, which means there are no x's left there. This other one, this minus 12, that 12 is not multiplied by anything. That's just a constant that's subtracted off the n, and so the derivative of that constant should be 0. This piece really does make sense if you think about it, because this part of the expression, 5x minus 12, if I drew a graph just of that part, y equals 5x minus 12, and asked for a formula for the slope of this is just 5 all the time, because this is a straight line with slope 5. So it makes sense that the derivative of 5x minus 12 ought to just be 5. So here we see some examples with fractional powers, and again, we just have to not freak out because the rule still applies. The rule says leave the 2 alone, and now the derivative of x to the 1/4 should be 1/4. In other words, that the power of x here was 1/4, so that comes out front. And then I should have x to the power. The new power should be 1 less than the old power. So this is actually something you may even have to come over here on the side and just figure out. 1 less than 1/4 is negative 3/4. So negative 3/4 is going to be the power of x in the derivative. Similarly, I'll write down here so I don't run into my other thing. Similarly, the second term, the 3 just sits there. I don't do anything with the 3. The derivative of x to the minus 1/3, the minus 1/3 comes out front. And then I have x to the power that's 1 less than that. So I have to figure out what 1 less than 1/3 is. If you do minus 1/3 minus 1, that's negative 4/3. So the new power here, the power in the derivative, should be negative 4/3. So you see that the only thing that's tricky about this rule is that because it applies all the time, we do have to subtract 1, do 1 less than numbers no matter what they look like. Now we're going to look at a few problems where the question, it doesn't start looking like the form that we said we like. We like it to look like a number times the power of x. That's our favorite form for the thing to look like because we can always apply the same rule. There are some exceptions to that, just in the way normal people write mathematics. So when it happens that we do not have the whole thing looking like number times power of x in all of its terms, we should take a second to rewrite the expression. So I'm not finding the derivative yet. I'm just simply going to rewrite what f of x is so that it does look like a number times the power of x. So what I need to know here is that the square root of x is really the same thing as x to the 1/2 power. If I know that, then this means exactly the same thing as the original problem. And once it looks like this, then my rules apply just like they did before. So my 6 sits there, my derivative of x to the 1/2 is 1/2 x, and now I have to have 1 less than 1/2, and that one I can actually do. 1 less than 1/2 is negative 1/2. I leave my minus sign like it is, and the derivative of x squared is just 2x. There's no number in front to worry about. Similarly, when you see these other radical symbols, let's write RW for rewrite. It's easier with this pad. The rewrite here, this is a cube root symbol, and so cube root is just x to the 1/3 power. So again, that's not finding the derivative, that's just rewriting the original expression so that I see x to a power instead of seeing any other kind of notation. If I use my regular power rule, the 1/3 power, the 1/3 comes out front, and then I'll have a new power that is 1 less than the original. So I have to subtract 1 from 1/3. My new power will be negative 2/3. The plus here, I have to add the derivative of this guy. Well, notice that this doesn't have any x's in it at all. So that means that that's just adding on a constant with no x's, the same way that we had up here, adding on or subtracting the 12 here, was just adding on a constant with no x's. So the derivative of that piece should just be 0.